Hello, this is the solution in lesson 5. I believe this is part 1, the force section, and it's question number 13. So we have a man weighing 70 kilograms lying on a hammock. The ropes make angles of 20 and 25 degrees. So we are assuming that we got pretty straight ropes here. So there's no curvature at all, and we're going to say that that 70 kilogram gentleman is a point weight, because that's really the only way you can do this question. So for the people that haven't taken physics before, this is where that trick is going to be. It's something that you're not comfortable with. It's just mass times gravity. So I'm going to say there's a lot of people that that's where it's probably going to stumble you. I'm going to use gravity of 10 just because it's no decimals. It's a lot easier for me. So the force applied is 700 newtons, and we want to know tension 1. And we want to know tension number 2, and they give us the angles respectively 20 and 25. So as I said in an earlier video, the Z pattern is all important because I'm going to assume that this point, different color, is my origin. All the vectors are coming out of there. So using the Z pattern, I'm going to be able to find the angles with respect to the x-axis. Different color for this one. There we go. That is a pretty ugly color, but anyway. So we can see that the angle over here is 25 degrees, and this angle here is 20 degrees. So now some people are going to do this algebraically, and there's an example like that in the note. I want to show you that this is one of the rare situations that geometric is actually quicker. And just to give you an idea of how that vector addition can work. We know because this man is laying in the hammock, he's not moving, so that we know if we add the 3 vectors together, T1 plus tension 2 plus the force, it has to equal the 0 vector, okay? Because he's not moving, so they all have to add up to 0. So if I go ahead and do this addition, so the first vector I draw is T1, so there's T1 at 25 degrees. T2 is going to start where I finished off. So here's T2, and it goes over here, and it's at 20 degrees. And finally, it has to create a closed triangle. So I've kind of cheated because I knew what it was going to look like. It has to create a closed triangle, and that force is, that F force is vertical. So I'm going to draw the closing part of that triangle with the force vector. Okay, so there we go. We have a closed triangle, and there is our Z pattern, so 25. So I know that the angle is going to be 45 degrees. So I can now find, I can go ahead and find a couple of values. Actually, this is simpler than I thought now that I look at it. I know that because this force vector is coming straight down, it's perpendicular down there, right? So it'd be a right angle, which means that angle is going to be 90 minus our 25, and we now no longer need the cosine law at all. So this is 65 degrees. And then 180, take away 65, take away 45, gives us 70. So that means we can go right to sine law. So we know that the magnitude of T1 over sine 70 will equal the magnitude of T2 over sine 65, which will equal the magnitude of our force, which we know. So we'll just go straight into 700 over sine 45. So if you use the algebraic method, I have pretty much an identical example in the note. So if you want to take a look back at that. But if you're going with the geometric method, it actually turns out, like I said, to be a little bit quicker here once you have your picture set up. So we can set up our ratio. So T1 is going to be what makes that work. Magnitude of T2 is going to be what makes this work. So we multiply those denominators up, and I'm just going to write down final answer here. So we have 700 times sine 70 divided by sine 45. And you get the magnitude of T1, or the tension in the first rope, is 930 newtons. And the next one, 700 times sine 65 divided by sine 45. We get 897.2 newtons. So that'll be a little different from the answer that's provided. They probably use 9.81 for gravity, but I got an engineering background, so going higher than 9.81 adds a safety factor, so you don't have to worry about the ropes breaking. So there you go. There's a geometric solution for that. Like I said, the algebraic one, pretty much identical to the one in the notes. Anytime you have no motion, so anytime there is no motion, so any object hanging, a sign hanging question, then you know the sum of your vectors. So for example, tension plus compression plus the force of the hanging sign. If the sign's not moving, it's going to add up to your zero vector. So you know you can draw a closed triangle. And usually through geometry, you can find those internal angles. So hopefully it gives you a little bit different look at this particular question.